Today we're going to do a review of some of the concepts that you may see on the MCA that we've already covered this year, but this will give you a little bit of a refresher. We're going to start with talking about converting among some of the linear forms of an equation. This is the formula sheet that you will have a paper copy of, and it is also a different tab on the MCA tests that you can pull up. But you can see here the highlighted things that I have that include slope-intercept form, point slope form, and standard form. So just know that these forms are listed on your formula sheet in case you do forget. So make sure to reference those if you ever come across a question on the MCA that talks about a different form of a linear equation. It might help you out and remind you what it should look like. The first one we're going to do, and we're only going to focus on slope-intercept form and standard form in this video, but we are going to take this equation right here that is in standard form, and I can tell it's in standard form because the x and the y are on the same side, and I am going to convert it to slope-intercept form. Now I know that slope-intercept form is going to be y y equals mx plus b. And remember, if I didn't know that and it asked me to convert it to slope-intercept form, I can look at my formula sheet and remind myself, oh yeah, I need to get y by itself. So that's my goal. I'm trying to get this y all by itself. So I'm going to move things around to get y by itself. So I'm going to move the thing furthest away. I'm going to move the 3x, and to get rid of 3x, I'm going to subtract 3x. That's going to make this go away. So I'm left with negative 2y. And then on the other side, I have 4 minus 3x. Now remember, I can't combine the 4 minus 3x because they're not like terms. So I'm going to leave it like that. The y is still not by itself. So I'm going to divide by negative 2 because right now the negative 2 is being multiplied by the y. And then I am going to divide everything on the other side by negative 2 as well. So that's going to get me y equals 4 divided by negative 2, which is negative 2. And then if I take a negative 3x divided by a negative 2, a negative divided by a negative is a positive. So I'd have plus 3 over 2x. Or I could change that. That's a pretty nice decimal. I could change that to 1.5x as well. So now just a side note, if I was ever asked like, all right, so from here, what's the slope? I don't know the slope here, but down here I would know the slope is 3 over 2. And I know now what the y-intercept is as well. So if you're asked for specific things, changing it to slope-intercept form will help you find that slope and the y-intercept. On the next one, you are going to see that this time we're going to convert to standard form. So standard form is going to be in the form of ax squared, or not ax squared, ax plus by equals c. So I need to get x and y on the same side. The other thing that we talked about is that the standard form has a couple extra rules. It cannot have fractions or decimals, and the first number can't be negative. So a is positive. So I'm going to start out with getting x and y on the same side. So I need to move this half x to the other side. So I'm going to move half x there so that this goes away and is now on the same side as the y. And then I check, does it have fractions and is a positive? Well, the first number is positive, half is positive, but it does have a fraction. So if it's a fraction, I'm going to multiply the entire thing by the common denominator. So I have one fraction, I'm going to multiply it times the denominator, so 2. So if I do, and I'm going to distribute this 2 to everything in the parentheses so the entire equation. So 2 times half x, 2 times half is going to be 1, so 1x. 2 times the y is 2y, and 2 times 5 is 10. So my final answer would be 1x, or sometimes you'll just see it as x. 1x and x are the same, plus 2y equals 10. So in this one, I'm asked, is it parallel, perpendicular, or neither? When I look at these equations, the mistake some people will do is they'll be like, okay, I just need to look where the x is. There's my slope. And I know parallel equations have the same slope and perpendicular equations have opposite reciprocals. And they say, there's the x, there's the x. Nope, nothing. They're not the same. They're not opposite reciprocals. But in order to know the slope, both of these have to be in slope-intercept form. So I can't look at the equations as they are. I need to change them to slope-intercept form. So I'm going to go and I'm going to change this first one to slope-intercept form. All I need to do is get y by itself. So I'm going to divide by 5. So I get y equals, now it helps me here if I think of this as a 1x because it's easier for me to see that fraction. So I have 1/5 x and then 10 divided by 5 is 2. Okay, so now that one I can see that my slope is 1/5 because it's by the x, it's in slope-intercept form. So let's go to the other one. I have 20x plus 4y equals 3. So it's in standard form. I'm going to start with getting the x on the other side. So then I'd get 4y equals 3 minus 20x. And then divide it by 4 because I'm getting y by itself. So y equals 3/4. Negative 20 divided by 4 is negative 5x. So now my slope here is the 1 by the x. So my two slopes, I have 1/5 and negative 5. So they aren't parallel because they're not the same slope. Perpendicular means opposite sign, which they are. One's positive, one's negative, and the reciprocal. And they are that. So 1/5, the reciprocal of that, you'd flip them. So it'd be 5/1 or 5. So these are going to be perpendicular lines. So linear relationships were something that we spent a whole bunch of time on this year. So one thing that we practiced a lot was graphing a linear relationship. So in order to do that, you do need it in slope-intercept form, which both of these equations are. But if they aren't, you're going to have to convert it to y equals, and then so that we know the slope and the y-intercept. So the thing that you need to know is when you are starting graphing a linear relationship, you always start by plotting the y-intercept first. So the 2 is the y-intercept, and that is going to be where it crosses the y-axis. So that's my first point. Then I'm going to use the slope. So it's a positive slope, so I know it's going to be, so slope due tells me it's puff, puff, positive. So I'm going to be going slanted to the right. So 1/3, the 1/3, this is my rise over run. So I'm going to go up 1 over to the right 3, which will give me a positive slope. If I run out of room, I could go down 1 and over to over 3 this direction and see how it's still positive. So this would be my line. Then let's say I'm graphing y equals negative 2x minus 1. So start with your y-intercept, always the first spot. So negative 1 is going to be down here. And then negative 2 is my slope. So sometimes it helps if you think of this as negative 2 over 1, because then I can see the rise over run. So this time it's a negative slope. I'm going to go down 2 over 1. See how the line's going a different direction? That's because it's a negative slope. I could also go up 2 over 1 to the left. But again, it's a negative slope. It's going the opposite direction. And that would be what the line looks like. So going the opposite direction, sometimes you'll have the graph and you need to figure out the equation. So we will need to know what is the slope and what is the y-intercept. So I usually start with the y-intercept. I'm going to do the pink line first. So the y-intercept appears that it's at 2. So I know that that's going to be my y-intercept, a positive 2. The slope, this is where you need to find those nice points that we talked about, where you look to see where it intersects, kind of like on those, the grid lines of the graph paper. So I see one there and I see one here. See how it's a nice intersection point? And then I draw those stairs. I say, here's the rise over run, rise over run. So it went up 3 over 1, up 3 over 1. Now, Do be careful because this graph, it's not labeled, so we assume it's going up by ones, but sometimes it could be going up by fives or tens or twos. So you're not always going to count the boxes. Sometimes you have to count by whatever the graph is going up. This time my rise is 3 over 1. So when I simplify that, I get a slope of 3, and it's a positive slope. So that's the equation for the pink line. So then if I'm looking at the green line, same deal. I start with the y-intercept. I always start with the y-intercept. That one is going to have a y-intercept of -1. And then the other nice points here, I see one there. I see one up here. So my rise over run, up 2 over 3, and you're going the negative direction there. This is a negative slope. So my slope on this one is 2 over -3, or -2/3, I could write it as. And that would be my equation for that line. The next thing we're going to review is scatter plots and line of best fit. So remember, scatter plots are going to be points that are just scattered all over the graph. A lot of times this is when there's data and different things plotted on the graph that's not exactly a linear fit. So you can see on this first one, this one is going to be a positive correlation. It could be correlation. Sometimes it says trend. Sometimes it says association. But you can see if I'm looking at these points, see how they're following in a positive direction. This line is the line of best fit. It's going like a positive slope. No correlation is going to be when there's not really a trend. There's nothing in common about the points. They're just all over the place. Negative is going to be when these points, as you're going from left to right, they're decreasing, like a negative slope. So that would be a negative correlation. So when you're doing a line of best fit, remember your line is really going to go in between the points. You really want half of the points above, half the points below. This graph is going to be a positive correlation. You can see the trend is that the points are increasing as you go from left to right. So my line of best fit is going to look something like this. That's a pretty good line for me. I usually extend it all the way back to the y-axis as well. So my line of best fit is going to go through those, and then the thing that you can do is you can use that line of best fit to help you answer questions. For instance, what if the question was something like, when the temperature is 20, what would the sales be? So then I can look at 20 and I can go up to the line that I just drew and use that to estimate. So the line can help me make some predictions, and it can help me see a trend. I could also, if asked, I could use that line to come up with an equation. So there's some different things that line can be helpful with. So sometimes you may be given a scatter plot and they already drew the line of best fit, and they want you to take a look at it and figure out what is the equation that would match this line of best fit. So really I'm looking at that line. I ignore the points, look at the line, and I have 3 options here. When you have several options, always a good strategy to look to see, do any of these not make sense? Can I eliminate one? So when I look at these 3, the thing that I see is that this one has a -10 for a slope. If I look at this graph, this is a positive correlation. The line has a positive slope. So I know that this is not correct because it is not a negative slope. It's not decreasing. So then the thing about the first 2 equations, it has the same y-intercept, which this appears to cross at the 45. So I need to think, is the slope 1, because that's what this would be, 1x, or is it 10x? So I'm going to find a couple nice points to use. So if I'm looking like there and there, if you look at what's happening here and draw the stair, you can kind of see what I mean there. It's going up 1 over 1. Now, some people might be 1 up over 1, that means 1. But if you look over here on the side, we are not going by 1s. We are actually going by 5s, because if you see right here, this is 5, 10, 15, 20. So I actually went up 5 here. And then when I look at the bottom, I am not going by 1s either. I'm going by halves. So when I go over, it's going to be 0.5. So my slope is actually 5 over 0.5. And if I divided that, 0.5 that, or 5 divided by 0.5, it's going to give me the 10. So here is my equation that goes with it. So then once you have the equation, you can predict something based on this situation. So it says use the equation to predict a student's score after studying 6 hours. So see how 6 hours is not on the graph. It only goes up to 4.5, and it's kind of hard to know like what's going to happen after this. So I can use this equation by saying, all right, the x is the study hour. So I'm going to put 6 into the equation, and I'm going to figure out what that would be. 10 times 6 is 60 plus 45. So that would be 105. So that would be my prediction of the score. All right, final topic that we are going to cover is evaluating expressions. So this is something we did way back at the beginning of the year. And it's not something that is super hard. It's just sometimes kids forget what they have to do or what it means. So for this one, it's worded, what is the value of -3? And then it has absolute value of -2x minus y when x equals -4 and y equals 5. So what it wants you to do, it's giving you, it's giving you the values of x and y. So you're just going to plug it in. So I'm going to just take out the x. So -2 is next to the x. So that means multiplication. I usually put the parentheses around to show multiplication. Otherwise I get confused, or I put a dot and it looks like a minus or something. And then minus y, which is 5. And then my absolute value symbol. So see how all I did was I took this x out and replaced it. I took this y out and I replaced it. And then I actually do the math. I evaluate. In math, if you hear the word evaluate, evaluate means figure out the value. If you can hear the word value in that, see, it wants you to find the value. So I'm going to actually figure it out. Absolute value is like a parenthesis. So according to PEMDAS, I start with parentheses. So I'm going to start inside, and I'm going to do -2 times -4, which is 8. So I'd have 8 minus 5. And I can see that that would be 3. The absolute value of 3, which absolute value, remember, is how far is it from 0? Well, 3 is 3 away from 0. So that's going to leave me with -3 times 3, which is equal to -9. So the value of this after I evaluate it is -9. And the final problem, this is another way that it might say it. It might actually say evaluate when m is equal to -3 and n is equal to -9. So it's telling you to evaluate, figure out the value. So again, I'm just going to plug into the m and the n, keep everything else the same. So 3 is being multiplied by -3, minus 2 is being multiplied times -9. And that's all in the square root symbol. So I'm going to start inside that square root symbol and simplify it. So 3 times -3, that gives me -9. And then here you can think of this as a -2 and a -9. That's a positive 18. So when I finish up simplifying the square root, -9 plus 18, that's going to give me 9. So I'm left with the square root of 9 and then 2 on the outside. So I need to figure out square root of 9. 9 is a perfect square, so the square root of 9 is 3. So the final step is going to take that 2 on the outside, mean it's going to multiply times 3 because the square root of 9 was 3. So I get 6 for the answer. So see how I get the value of that? I end up with one number. So if I just went through a whole bunch of things pretty quickly, remember, if there was one thing that you didn't totally get, go back in the video, watch that section again, because that might help you understand it a little bit better. Sometimes you need a little bit more time to refresh how to do that. So like I said, these are a few things that you might see in the MCA. Just wanted to refresh your memory about things that we've done this year. Let me know if you have any questions.